In section 6.3, we're going to look at another application of integration, and that's to find the arc length. If you were asked to find the length of a line segment from a straight line, that's very easy to do. We have the distance formula for that. But without calculus, you could not find the length of a curved segment. And the formula that we're going to be using comes about by taking a curve and breaking it into small segments and then approximating the length of each of these segments with a straight line. And as you add up the lengths of those straight line segments, you're going to approximate the length of the curve. Just for the sake of time, I'm not going to go through the entire process as to where the formula exactly comes from, but if you're interested, there's a really good explanation in the textbook. But we end up with this formula here, and it's written as a definition. If f prime is continuous on the interval AB, then the length of the curve y equals f of x from point A to point B is given by the integral from A to B of the square root of 1 plus the derivative of f squared dx. We can use this formula then to find our length of curves. And it's actually fairly easy to use. We're going to do an example here. Given the curve y equals 3/4 times x to the 4/3 minus 3/8 x to the 2/3 plus 5, we're going to find that length when x is going to go from 1 to 8. And here I have a picture of it. The curve is in red, and then the blue line represents x equals 1, the green line x equals 8. So we're going to just go ahead and use this formula. So first thing I need is the derivative of y. So we'll go ahead and do that first. So dy dx. Oops. And it would help if I had my pen turned on. So taking the derivative, we have 3/4 times 4/3 x to the 1/3 power minus 3/8 times 2/3 x to the negative 1/3 power. And then, of course, the derivative of 5 is 0. So cleaning this up just a little bit, the 3/4 and the 4/3, of course, are going to cancel out. So we have x to the 1/3 minus 3/8 times 2/3 is going to end up reducing down to 1/4. So we have 1/4 x to the negative 1/3. So that is our dy dx. So we're going to go into that formula. So the length of this red curve here is the integral from x equals 1 to x equals 8 of the square root of 1 plus that derivative squared. So we have x to the 1/3 minus 1/4 x to the negative 1/3 squared. Now we're going to do a little bit of algebra to clean things up inside that radical. I'm going to go ahead and multiply out that x to the 1/3 minus 1/4 x to the negative 1/3 squared. So we end up with x to the 2/3 minus 1/2 plus 1/16 x to the negative 2/3. Keep in mind the inside terms, when you take x to the 1/3 times x to the negative 1/3, you're going to add the exponents, you end up with x to the 0 power, which is 1. That's why we don't have an x term in the middle. Now taking this, adding the 1 and the negative 1/2, is going to give us x to the 2/3 plus 1/2 plus 1/16 x to the negative 2/3. And now we're going to go right back and factor this. X to the 2/3 plus 1/2 plus 1/16 x to the negative 2/3 is going to be x to the 1/3 plus 1/4 x to the negative 1/3 quantity squared. So it might seem like we undid something to do it back up again, but this is going to allow us to get rid of the square roots. So when you take the square root of something that's squared, they're going to cancel each other out. So we're just left with the integral from 1 to 8 of x to the 1/3 plus 1/4 x to the negative 1/3. When we integrate, we're going to end up with 3/4 x to the 4/3 plus 1/4 times 3/2 x to the 2/3. And we're going to evaluate that from 1 to 8. 1/4 times 3/2 is going to be 3/8. So when we evaluate it, I've got 3/4 times 8 to the 4/3 power. The cubed root of 8 is 2. 2 to the 4th is 16. So we have 3/4 times 16. Like I said before, this is going to be 3/8. 8 to the 2/3. Again, cubed root of 8 is 2. 2 squared is 4. Now we'll evaluate with the 1. So it's going to be 3/4 times 1 plus 3/8 times 1. So we work this out. 3/4 times 16 is going to be 12. 3/8 times 4 is going to be 3/2 minus 3/4 minus 3/8. If you create a common denominator and then add all of these together, you're going to end up with 99/8. So the length of this red curve here between the point where x equals 1 and the point where x equals 8 is 99/8 units.